Hey, it's T. I'm one of the geniuses at AskZylor. So let's just get started with the live session.
Hey, let's get started. So once again, we're going through some grade 11 problems. So we're going to go through some of the questions that you see in the quadratics unit. So we're just going to review some factoring methods. So the first question is asking factor two equations, and we're going to go ahead and do them and show the differences and similarities of factoring and the common steps you would usually take. So what we first do is, when we get a question like this, we need to analyze what kind of equation is given to us. So what I mean by that is, we need to kind of analyze what the leading coefficient is. If the leading coefficient is 1, that's great. We're going to take one approach, and if the leading coefficient is anything other than 1, we're going to take a different approach. So for this equation, for any equation given, we should be always looking at, is there any common term that I can factor out? There's 1, 11, and 24, so I can't really factor anything out in that, so I'm just going to go ahead and get started. So if my leading coefficient is just 1, that means all I'm looking at is my C term, my constant. So I have 24. If my leading coefficient is not 1, I'm going to look at my leading coefficient and my constant term. So I'm going to get 2 and 8, and I'm going to multiply them to give me 16. So once I get these two numbers, what I'm going to look at is, what are the factors for these numbers? So for 24, I have 1 and 24, I have 2 and 12, I have 3 and 8, and 4 and 6. Right? So once I get these factors, the next step is to see what the signs are. I have plus and plus. That means I just need to pick two numbers which are both positive that add up to my B value, which is 11. So which pair of numbers add up to 11? It's not going to be this, it's not going to be this, it's going to be 8 plus 3. So what I'm going to do then is, I'm going to substitute 8 and 3 into the equation, so by splitting up my 11x. So I have x squared plus 3x plus 8x plus 24. Then I can factor by grouping, so I'm going to group the first two terms and the last two terms, and then factor out any common terms in both the brackets. So in the first bracket I can factor out an x, so I have x plus 3, plus in the second brackets I can factor out an 8, so 8x plus 3. So then I have the same term inside my bracket, so I can factor out the 8 plus x plus 8. So then I have x plus 8, and then x plus 3. So if you're just joining in, we're going through some questions in the quadratics unit in grade 11 functions. So that's what we'll be mostly focusing on for this live session. If you have any questions you want us to answer, please send them in. We'll be happy to help you out. So let's go ahead and try and factor the next equation. So once again, I said my first step should be to see if there's any common terms that I can factor out. So it looks like I can factor out 2 from each of these terms, so that I'm going to go ahead and do that. So y is equal to 2x squared plus 5x plus 4. Then I'm going to go ahead and take the same steps as before. So I just need to look at the C value, which is my 4 now, and then try to see what are my factors for 4. So it's either 4 and 1 or 2 and 2. But then I need to see which one of these factors, pairs of factors, is going to add up to give me 5. So the only one that adds up to give me 5 is 4 and 1, not 2 and 2. So I'm just going to rewrite that down here. So I have y is equal to, I factored out a 2 to give me x plus 5x plus 4 And then I determine that my factors are going to be 4 and 1. So I'm just going to put the 1 in front. So y is equal to 2x squared plus x plus 4x plus 4. And then I'm going to group the first two terms and the last two terms. So I can factor out an x from the first two terms to give me x plus 1, and a 4 from the last two terms to give me again x plus 1. So my two factors are going to be x plus 1 and x plus 4. So this is my factored form for that equation. So we have a question that's asking, is it grade 11? I'm in grade 10 and I'm learning that right now. So this is great. You learn this in grade 10. We need to review this for grade 11 as well, because we need to understand factoring and understand quadratic functions. So we'll move on to the next question. So it's similar. It's saying find the roots of y is equal to negative x squared minus x plus 12. So this is very similar, because the roots mean we need to find the factored form of this function. So roots have many synonyms. So we could have roots, we could have zeros, we could have x-intercepts. We could also call them solutions to quadratics. So all of them basically mean we need to find the factored form of the function. So once again, we're going to try and factor this, but this is a little different. We have a negative coefficient, so we don't really like negative, so we're going to try and factor out the negative 1. So I'm just going to put a negative outside to give me x squared plus x minus 12. It makes factoring a lot easier. So the next step is, once again, we're going to analyze negative 12. And then find factors for negative 12 that add up to plus 1. So it could be 4, 3, 6, 2, 12, 1. But which one of them can add up to plus 1? It should be a difference of 1. So we have 4 minus 3 can give me 1. So that means I'm going to introduce x squared minus 3 plus 4 is both with x minus 12. So then y is equal to, I'm going to group the first two, last two to give me x plus 4, x minus 3 as my factors. So they're asking me what are the roots of this function. So what we're doing right now is just refreshing some factoring for finding some quadratic factors. So we went through some synonyms for factors. We can call them roots, zeros, x-intercepts, solutions, but they all mean the same thing. We're trying to find what are the x-intercepts, and we can find that out by factoring our function. So the next step is to see when each of these terms are equal to 0, because my x-intercept is when y is equal to 0, so I can sub in 0 for y and leave the rest of the function the way it is. So the only way I can get y is equal to 0 is if one of these terms are 0, so that 0 times any number is just going to give me 0, right? So then I'm going to go ahead and equate each of these terms to 0, so x plus 4 is equal to 0, so x has to be negative 4, and then x minus 3 has to equal 0, so x has to equal positive 3. So my roots are my zeros, are my solutions, are my x-intercepts, all of these mean the same thing. So what are they? So I have x is equal to negative 4 and x is equal to 3. So that's how I go about finding the roots of this function. So determine the vertex and direction of opening of the following quadratic equation. So we're given an equation and we need to find the vertex and direction of opening. So to find the vertex, we're going to complete the square. So we're going to go through what those steps look like, And then you can apply those steps to any quadratic function to always get your vertex. So I'm just going to rewrite the equation: 12x squared plus 144x plus 30. So if you're just joining in, we're going through some grade 11 functions questions. So the first step of completing the square is factoring out the common term factoring out the leading coefficient from the first two terms. So I'm going to factor out 12 from the first two terms. So then I'm left with x squared plus 12 plus 30. I'm not factoring out the x's, I'm only factoring out the leading coefficient. The next step is to see what this value is. I'm just going to call it b. And then divide it by 2 and then square it. You'll see why we do that in a second. So my b value in this case is 12. 12 over 2 squared is going to be 6 squared. In other words, it's going to be 36. So what I'm going to do is introduce the constant 36 into my expression. So y is equal to 12 x squared plus 12x plus 36. But if I just introduce 36, that means I'm changing the expression, I'm changing the function. I can't do that, so I'm just going to introduce a negative 36 as well to balance things out. So the next step is to get rid of the negative 36 by getting it outside the bracket. So negative 36 times 12. So I only have my positive 36 inside. So negative 36 times 12 is going to be 432 plus 30, and that simplifies to negative 402. If you're following along, we're just reviewing some factoring, and then we're moving on to finding the vertex form of quadratic equations. So then we're going to move on and try and factor this. So completing the square essentially means we're getting a function with 1x and a constant added at the end. So we don't really care what this a value is, we only care about what the constant added at the end is and what is x added to in the middle. So the reason we did b over 2 squared is because we're trying to square one factor to give me x squared plus 12x plus 36. And that one factor is x plus, what was b over 2? 6. It's going to be x plus 6. And I still have 402 left. So this is my vertex form. So I can double check and show you that x plus 6 squared is going to give me x squared plus 12x plus 36, so I can distribute each of these numbers. So I have x squared plus 6 times x is 6x, that's times 6x plus 6x plus 6 times 6 is 36. So all in all, I should get x squared plus 12x plus 36. This is just to prove that x plus 6 squared is going to give me this function. So I got into vertex form, right? But they're asking me to tell them what the vertex form exactly is. So I'm going to get that by two numbers, this and this. So the general equation for vertex form is going to be ax minus d plus h. And then your vertex is going to be at d and h. So notice that it's minus d, so that means any number inside the brackets I need to negate it. So I have a plus 6, so my vertex is going to be minus 6 at x equals minus 6, and then my y value stays the same, so negative 402, so my y is going to be negative 402. So my vertex is at negative 6 and negative 402. So that's my vertex. So the following quadratic, they're also asking me the direction of opening of the following quadratic equation. So the way to find that is, the only thing we need to look at is what's my leading coefficient. Is it positive or negative? So in this case, I have plus 12 x squared. I'm only interested in the sign of the coefficient, so it's going to be plus 12. Now, if I have plus 12, what that tells me is my function is always going to open upwards. If it was minus 12, that means my function is always going to open downwards. That's all I needed to know. So if it's positive 12, the direction of opening is going to be upwards. Sorry. So my direction of opening is up. And I've answered the question. I found my vertex, -6, -4, 2, and the direction of opening is up. So the next question is asking inverse of a quadratic function. So find the inverse of the following quadratic function and state any restrictions required. So the usual way to find the inverse of a function is we exchange the x and y's, and then we isolate for my y, right? So if we were to do that, we'll replace each of the x's with y's and the y's with x's. We have 3y squared minus 12y plus 7. We have two y terms and it's hard for us to isolate the y. So what we're going to do is turn this function into the vertex form. Because if you remember, the vertex form is in the form of x minus d plus h. Right, we only have one x term, so when we exchange the x and y's, we only have one y term for us to isolate. So let's go ahead and find the vertex form for this. So we have y is equal to 3x squared minus 12x plus 7. So we go ahead and factor out the 3 from the first two terms, x squared minus 4x plus 7. So then 4 I'm just going to divide it by 2 and then square it to give me 2. 2 squared. And then y is going to equal 3x squared minus 4x. Again, if I introduce a number, I need to introduce the negative number so that I don't change my expression. Right. So I'm going to go ahead and simplify that. I'm going to get rid of the negative 4 outside. So negative 4 times 3, I have 12. So x squared minus 4x plus 4, I have negative 12 plus 7. So once again, we're going through the question which asks us to find the inverse of a quadratic function and to state any restrictions required. So we went through and we are going and finding the vertex of the function so that we only have one term for us to interchange the x and y's with. So I'm almost done finding the vertex form of this equation. The square for this is going to be x plus 2 squared. So it should be x minus 2 because this sign is negative. And then negative 12 plus 7 simplifies to negative 5. So now I have it in vertex form. Now I can go ahead and find the inverse of this function. I'm going to interchange the x and y's. So I have x is equal to 3y minus 2 squared minus 5. So then I'm going to go ahead and isolate for my y. So I have x plus 5 over 3 is equal to y minus 2 squared. Right. I brought the 5 over, I brought the 3 over, and then I'm going to get rid of the square by square rooting both sides. So when I square root, I can have a plus or minus. So I'm just going to make it simpler. Y minus 2 is equal to plus minus square root x plus 5 over 3. And then I'm going to bring my 2 over to finally give me plus 2. So I have y is equal to plus minus square root x plus 5 over 3 plus 2. So I came up with the inverse of a quadratic function, but if you are familiar with square roots, it's not going to be a function because it's not going to pass the vertical line test, right? It's going to take the form of something like this. So the question we're doing right now is saying find the inverse of a quadratic function and state any restrictions required. We went through, found the vertex form, interchanged the x and y's, and then we found the inverse of the quadratic. Right? But we have to state some restrictions so that my inverse is going to be a function. So I can basically pick one of these signs. I can make it either positive or negative, because if it's positive, I'm picking the top side of this function. If it's negative, I'm picking the bottom side of this function, and only the bottom side. So that means it will pass my vertical line test, because if I don't have the bottom half of this equation, of this function, it's going to pass the vertical line test, right? So we're going to go ahead and go to the next question. So we're still sticking with the quadratics unit. We found some review of some factoring. We went through, found the vertex of some from some quadratic equations. We found the inverse of quadratic equations as well. And now we're getting into some radical operations. So our question's giving us an ABC, and we're asked to find the area of the triangle. So the usual area, it's pretty simple. It's just going to be base height over 2. What's my base? It's going to be C. What's my height? It's A, right? So my area is going to be C times A over 2. And we have the C and A values right here, right? So let's go ahead and find what C times A is. So C times A is going to be square root 2 minus 2 is root 3 multiplied by 3 root 2 plus 4 root 3. So for this, we're just playing with radicals. Right, so we need to distribute each of these terms. Right, so then we have 3 square root 2 times square root 2 plus 4 root 2 times root 3 and then minus 2 3 4 3. I ran out of space, but that's fine. So what I'm doing is I need to see how these square roots into that. So what happens is I multiply the coefficients together, so 3 and 1 to give me 3, and I multiply what's inside the square roots together, so I have 2 times 2, right? So that gives me 4, and I know the square root of 4, it's going to be 2, so I'm just going to replace that with 2. Right. I'm going to do that for all the terms. So 4 times 1, 4, 2 times 3 is 6. Keep going, 2 times 3 is 6, root 3 times 2. Now it's a little different, right? We can't really simplify the square root, we're left with the square root of 6. And then minus, this is 8, square root 3 times 3 is 9. I know the square root of 9, it's going to be 3, so I'm just going to hit 3 here. Alright, so then I'm just going to simplify all this, so this is going to give me 6, Now these two terms have the same square root, so I can just add and subtract the coefficient. So plus 4 minus 6 is just going to be minus 2 square root 6. And then I have minus 24. So then I'm going to simplify this to give me negative 16. So, yeah, 8 times t, 24. Yeah. So negative 2 square root 6. And then minus 16. Sorry, this is going to be minus 18. So I found what C and A is, right? So all of this was to find the area of the triangle. I know that area of the triangle is base times height over 2. My base is going to be C, my height is going to be A. And then I need to divide that by 2. So I found what C and A is, right? It's negative 2 square root 6, negative 18. But I need to divide that by 2. So I can just simply divide each term by 2 to give me negative 6 minus 9, and that is my area. I don't need to simplify. If I want exact values, I can plug it into the calculator and tell me the decimal form. But I don't really need it. I'm just going to leave it as a square root. Right? So the takeaways from this is that when we're dealing with radicals, when we expand brackets, for example, we multiply the numbers inside the square roots together and put them under the square root. And if we're adding or subtracting the same square root, we can add and subtract the coefficients. So we're going to move ahead to the next question. So we're finally getting to some application questions. So these are very common questions that pop up. So it can be dealing with financial models and revenues. So in this case, we have a person and his son is opening up a dog grooming business. They calculate that if they charge $50 for every dog groom, they receive about 60 canine clients a month. So let's say $50, we get 60 clients. For every $2 they lower their price by, they see an additional 4 new customers. So if they subtract $2 from the price, they get 4 new customers, right? So we need to find a model that tells me the price multiplied by how many clients they have, because that is what revenue is going to be. It's cost times how many clients or products you have. So in this case, you have 50 minus 2x. My x is going to be how many times am I decreasing my price by, and for every time I decrease my price, my clients go up by 4. So I have 60 plus 4x. So that is my revenue. So what I'm going to go ahead and do is, they're trying to ask me what should they do to maximize their revenue. What should the maximum revenue be? So my maximum revenue is going to be when this function is at a max. Right? So I need to try and find the vertex of this function, because this is my revenue function. Right? So I'm going to go ahead and find the vertex. So if it's already in factored form, I'm not going to go and complete the square, because I can use the factors or the zeros that I can get from the factors to tell me what my vertex is. Because if I have 2 zeros, it's always going to be symmetrical. That means the midpoint between the 2 zeros is always going to be the vertex. So I'm going to go ahead and find when is revenue equal to 0 for each of these. So 50 minus 2x, x is equal to 25. And then 60 plus 4x, when is that equal to 0? When x is equal to negative 15. right? So I can't really be dealing with the negative, but that's not what I'm looking for. I'm trying to find a midpoint between these two zeros, right? So my midpoint is just the addition of the two zeros. So I have 25 plus negative 15 over 2 to give me 5. So that's my midpoint. In other words, my vertex has an x value of 5. Right? What does that tell me? That means my maximum is when x is equal to 5. So what should they charge to maximize their revenue? They should charge, they were initially charging 50, so I'm going to rewrite the revenue equation. It's 50 minus 2x times 60 plus 4x. Right? And I know my revenue is going to be maximum when x is equal to 5, so I'm going to plug in 5 for every x. So 50 minus 2 times 5, and then 60 plus 4 times 5. Right? So this simplifies to 40, this simplifies to 80. So what does this mean? So this is telling me the price they should be charging to get maximum revenue. This is how many clients they will have at maximum revenue. So the final question is asking me what is the maximum revenue. So it's 40 times 80, which is just 3200. So 3200. So we're going through some application questions for quadratics. So once again, if you missed the live session or you want to go back and watch it, you can hit the link in our bio. We'll upload this live session to our YouTube channel. You can also just watch the story as well. So we went through a quadratic financial applications question. So these are very common. You vary the price and you vary the product. So in this case, we started with, we're charging $50. If we charge $50, we have 60 clients, and if we reduce the price by 2, we get 4 more clients every time. So we modeled an equation for revenue, which is cost times how many products or clients we have, and then we had to find the maximum revenue. So we went and found the vertex of this revenue function. So we did that by finding the zeros, finding the midpoint of the zeros, because they're always going to be symmetrical. And then I found that x is equal to 5, we have a vertex. And then I went ahead and plugged 5 into my revenue function to find what my maximum revenue is going to be, which is 3200. And I found the price as well, which is $40 is going to maximize revenue. So financial application questions are very common. The other type of questions are geometric questions. You'll have shapes, you'll need to optimize your shape to fit a certain parameter. So in this case, you have a pathway. It's to be installed around a rectangular garden that is equal width all the way around. The area of the new pathway is equal to the area of the garden. What is the width of the pathway if the garden measures 10 feet by 6 feet? So we know the area of the new pathway is equal to the area of the garden, right? So that means whatever's inside, the area inside is the same as the area outside. So my total area is going to be twice the area of the inside, right? So I have 10 times 6 times 2. So I have 120 feet squared. So I'm going to write some equations. So I'm going to write the equation for what the area of the inside is going to be. So the area of the inside is just 10 times 60. 10 times 6 to give me 60. And the area of the whole thing is going to be total, is going to be 10 plus 2x is going to be the total length, and my width is going to be 6 plus 2x, right? Because my path, there's 2 x's in each length and width. But I need to find the width of the pathway. So the area of the pathway is going to be the same as the area inside, so it's going to be 60 as well. So my total is going to be this. So if I were to find just the area of the pathway, I know it's 120, right? But another way to find it is the total minus the inside, right? So I'm going to do 10 plus 2x, 6 plus 2x, and this is going to give me my total, and this is just pathway, but I know my pathway is going to be my total minus the inside, so my inside again is going to be 60. So my pathway is only 60 as well. So then I'm going to isolate and try to find my x values. So when I bring the 60 over, it becomes 120. So I have 10 plus 2x, 6 plus 2x, so I'm going to expand both these terms, make one side equal to 0. So I have 4x squared plus 32x plus 60. Then I bring the 120 over to give me minus 120. So then I have 0 is equal to 4x squared plus 32x minus 60. So what we're doing right now is we're looking at a quadratic geometric application question. We came up with a model. The model is the total area, the pathway, and the inside area. We know the pathway is going to be the total minus the inside, and we know the values of the inside and the pathway as well, right? So what we're trying to do is find the x value. And right now we have an equation that says 0 is equal to a function. So what we can do is find the zeros, or the x-intercepts, by trying to factor or trying to use a quadratic equation to try and find my x values. So let's go ahead and factor out the common term in each one, which is 4. So I'm going to get 4 out, so x squared plus 8x minus 15. So then I can't factor this, so I'm going to go ahead and use the quadratic equation. So it's minus b plus minus square root b squared minus 4ac over 2a. So for the sake of time, I'm just going to go ahead and show you the x value. So x is equal to 1.57, or x is equal to negative 9.57. We can't have a negative number because we're using in geometric applications, so we can't really have a negative distance. So we're going to use the 1.57. So my pathway has a width of 1.57 feet. So the question is asking what's the width of the pathway, and we've answered that. So that did take a while, so just to recap what we did. I know my total area is going to be 10 times 6, which is the inside area, times 2, because they told me the inside area and the area of the pathway are both the same. So I came up with 120 feet squared, and then I came up with an equation that said the pathway is equal to the total area minus the inside. And I know the areas of the pathway and the inside because they told me it's going to be 60 for each. And then I went ahead and isolated for my function. So I'm always trying to get an equation that's equal to 0 so I can try and solve for x. Because if it's equal to 0, that means my y is equal to 0. That means I'm looking for my x-intercepts. I'm always looking for my zeros or my solutions, my roots, whatever you want to call them. Then I factored out the common term, and I realized I can't factor it. You can try, but we can't really factor it, so we use the quadratic equation. Then I found two x values, so I found a negative and a positive number. But I can't have a dimension in the negative, so I used the positive 1.57, so my width of my pathway is 1.57. So that's how we go about solving these quadratic application questions. So we we reviewed some factoring, we did the vertex of quadratic functions as well. We did some application questions, the inverse of quadratics. So these are common problems you'll occasionally see. So if you have any questions, again, please feel free to send them in. We'll be happy to help you. So hope you guys enjoyed that session. So if you have any questions, again, send them in. So I'm signing out right now. So this is T from AskZylor. We're a service dedicated to helping students out. If you, once again, want any help with math, please send them in. We'll be happy to help you out. And have a good night. Take care.